Resilience enters lunar orbit, a historic milestone in lunar exploration. On May 6, 2025, the Japanese lunar lander Resilience, developed by the private company ispace, successfully entered lunar orbit, marking a significant achievement in the ongoing exploration of the Moon. This event is part of the HAKUTO-R M2 mission, which is set to attempt a lunar landing no earlier than June 5, 2025. The successful orbital insertion represents the culmination of months of meticulous planning and execution, showcasing advancements in private space exploration. Timeline of key events. 1. Launch. Resilience was launched on January 15, 2025 aboard a SpaceX Falcon 9 rocket, sharing the ride with another lunar lander, Blue Ghost, from Firefly Aerospace. This collaborative launch marks a growing trend of partnerships in private space endeavors. 2. Lunar flyby. On February 14, 2025, Resilience conducted a close flyby of the Moon. This maneuver was crucial for verifying the spacecraft's propulsion and navigation systems, ensuring they were ready for the challenges that lay ahead. 3. Deep space journey. After the flyby, Resilience entered a low-energy transfer orbit, spending approximately 2 months in deep space. During this time, it reached a maximum distance of 1.1 million kilometers from Earth, allowing it to conserve fuel and optimize its trajectory. For orbital insertion, the critical lunar orbit insertion maneuver took place on May 6, requiring a 9-minute burn of the lander's main thruster, which was the longest burn to date for this mission. This intricate maneuver was executed from the Mission Control Center in Tokyo, Japan, confirming ispace's capability to manage complex space operations. Key components of Resilience's mission. Landing site. The primary target for the lunar landing is near Mare Frigoris, a basaltic plain located in the Moon's northern hemisphere. In addition to the primary site, 3 alternative landing locations have been identified, ensuring flexibility in mission planning. Payloads. Resilience carries several scientific and technological payloads, including a micro-rover named Tenacious, developed by a Space European subsidiary. The rover is designed to explore the landing site and collect lunar regolith. An artistic installation called Moonhouse, created by Swedish artist Mikael Genberg, which adds a cultural dimension to the mission. Various experiments, including a water electrolyzer and a food production module aimed at demonstrating technologies essential for sustainable lunar exploration. Significance of the mission. The successful entry into lunar orbit is not just a technical achievement for ispace, it signifies a broader step forward in lunar exploration and the eventual utilization of lunar resources. The mission's success will serve as a foundation for future endeavors, including sustainable human presence on the Moon. The upcoming landing attempt is particularly significant as it follows ispace's first lunar lander, which unfortunately failed during its landing attempt in April 2023. Takeshi Hakamata, ispace CEO, expressed his satisfaction with the successful orbital insertion, emphasizing the operational experience gained from previous missions and the pride he feels in his team's accomplishments. "We have successfully completed maneuvers so far by leveraging the operational experience gained in Mission 1, Hakamata stated, highlighting the importance of learning from past missions. Common points across sources. Various sources confirm the successful entry into lunar orbit and the planned landing attempt. The significance of this mission is underscored by its potential to enhance lunar exploration and resource utilization. All sources highlight the operational capabilities demonstrated by ispace and the strategic importance of the upcoming landing. Differences between sources. While all sources agree on the successful orbital insertion, they differ in their emphasis. Source 1 Space News focuses on the technical aspects, detailing the maneuver's specifics and the mission's milestones. Source 2 Space.com highlights the cultural and artistic components of the mission, particularly the Moonhouse project, showcasing the intersection of art and science. Source 3 ispace Official News elaborates on the broader implications of the mission and future plans, including payload collaborations and upcoming missions. Future of lunar exploration. The Resilience lunar lander's successful entry into lunar orbit is a remarkable achievement for a space, setting the stage for upcoming missions aimed at exploring lunar resources and technologies. The planned landing on June 5, 2025 is expected to pave the way for further exploration and could play a critical role in establishing a sustainable human presence on the Moon. ISpace's ongoing commitment to lunar exploration is reinforced by its plans for future missions, including the development of additional lunar landers and partnerships with various organizations. With an eye on continued innovation and collaboration, ISpace aims to expand humanity's reach into space, ensuring that lunar exploration is not just a momentary endeavor but a sustained effort towards understanding and utilizing our nearest celestial neighbor. Conclusion. The successful insertion of Resilience into lunar orbit marks a pivotal moment in the field of space exploration. As ISpace prepares for the upcoming landing attempt, the implications of this mission extend far beyond its immediate objectives. It exemplifies the potential of private space companies to contribute to humanity's understanding of the Moon and to lay the groundwork for future exploration and resource utilization. As we look ahead, the achievements of the HAKUTO-R M2 mission will undoubtedly influence the trajectory of lunar exploration for years to come. Counterintuitive information. 1. Failing forward. The fact that ISpace's first lunar lander mission resulted in a crash does not typically bode well for a company's reputation or future endeavors. However, ISpace has leveraged this setback, claiming that they gained valuable operational experience from the failure, which they assert has contributed to the successful orbital insertion of the Resilience lander. This notion that a failure can be beneficial and lead to future success is counterintuitive, as failures are often viewed solely negatively in the high-stakes world of space exploration. 2. Fuel-efficient trajectories. Resilience's trajectory to lunar orbit was described as a low-energy transfer orbit, which may seem counterintuitive because it took longer, approximately 2 months, compared to a more direct route. This slower path was chosen to conserve fuel, which highlights an unconventional approach in space travel. Sometimes taking the longer route is more efficient and safer than a quick direct approach, especially in deep space operations. 3. Integration of art and science. The inclusion of a cultural artifact, the Moonhouse, by artist Mikael Genberg, along with scientific instruments and the Resilience lander's payload, reflects an unexpected blending of art and science in space missions. This juxtaposition might seem counterintuitive, as scientific missions are typically dominated by technological and engineering concerns. Yet integrating art into space exploration may enhance public engagement and interest in scientific endeavors. For our private sector innovation, the mission highlights the increasing role of private companies like ISpace in lunar exploration, traditionally dominated by government space agencies. The counterintuitive element here is that a private company, often perceived as profit-driven, is taking on missions that prioritize scientific exploration and cultural significance, suggesting that the private sector can contribute to humanity's broader goals in space exploration. 5. Small-scale, big impact. The Resilience lander and its payloads, including the micro-rover Tenacious, emphasize a shift toward smaller, less expensive missions that can still yield significant scientific results. This challenges the traditional view that major space exploration requires large, costly missions with extensive resources. The success of smaller missions could reshape expectations for future lunar and planetary exploration. 6. Cultural preservation in space. The inclusion of a UNESCO memory disk on the Resilience lander aimed at preserving linguistic and cultural diversity introduces a counterintuitive element of cultural preservation in a mission primarily focused on scientific exploration. This suggests that space missions can serve dual purposes, acting as vehicles for cultural significance while advancing scientific and technological knowledge. 7. Regulatory challenges and resource rights. The agreement with NASA for the ownership of lunar regolith collected by the Tenacious rover raises questions about property rights in outer space, which are not clearly defined under current international space law. This situation may seem counterintuitive, as it implies that private companies can negotiate rights to use lunar resources, potentially leading to a future where space resource utilization becomes a commercially viable endeavor. contrary to the notion that space is a global commons. 8. Diverse payloads from various contributors. The Resilience lander carries payloads from multiple organizations including private companies and a Taiwanese university. This diversity in contributions challenges the conventional idea that space missions are primarily the domain of national space agencies, underscoring the collaborative nature of contemporary space exploration. These counterintuitive elements illustrate a shift in the paradigms of space exploration where failures can lead to success as small missions can have large impacts, and the blending of art and science can enrich our understanding of the universe and ourselves. The successful entry of the Resilience lunar lander into lunar orbit on May 6, 2025 represents a pivotal moment not only for SpaceX, the Japanese company behind the mission, but also for the future of lunar exploration and the commercial space industry. While many aspects of this event have been reported, several critical details often receive less attention but are significant for understanding the broader implications of this mission. 1. The milestone of operational experience. One of the most significant yet overlooked aspects is the operational experience gained from SpaceX's previous mission, which ended in a failed landing attempt in April 2023. This past experience has informed the technical and operational decisions made for the Resilience mission, particularly regarding the 9-minute burn during the orbital insertion. CEO Takeshi Hakamata emphasized this point, stating that the team leveraged the lessons learned from their first mission to successfully execute this critical maneuver. This reflects a broader trend in the space industry where iterative learning and adaptability are crucial to achieving milestones in complex missions. The ability to respond to previous challenges and apply that knowledge can significantly improve the odds of success in future missions, which is vital in a field where failures can be costly and high-profile. 2. The cultural and artistic payload. Another often overlooked aspect is the inclusion of the Moonhouse model, an artistic installation by Swedish artist Mikael Genberg, as part of the lander's payloads. This project serves not only as a cultural artifact but also represents a blending of art and science. It challenges the notion of lunar exploration being solely a technical endeavor and introduces a more humanistic perspective. This cultural dimension is significant as it highlights the potential for space to inspire creativity and foster a sense of shared human heritage. By carrying art to the moon, space is engaging with the public in a way that transcends scientific achievement, potentially drawing more interest in lunar exploration and space missions overall. 3. The role of international collaboration. The Resilience mission exemplifies international collaboration in space exploration, as it carries payloads from various entities, including a deep space radiation probe from Taiwan's National Central University and a food production experiment from Japan's Euglena company. This collaborative approach underlines the importance of partnerships in advancing space exploration capabilities. It also signifies a shift towards a more globalized perspective on space endeavors where resources, knowledge, and technology are shared across borders. Such collaboration is essential for achieving the ambitious goals of sustained human presence on the moon and beyond. 4. The broader implications for lunar resource utilization. The mission's objectives extend beyond mere exploration. They include demonstrating technologies for lunar resource extraction. The Tenacious micro rover, which will collect lunar regolith, is particularly noteworthy as it is part of a larger initiative to establish rights to lunar resources through a contract with NASA. This aspect of the mission addresses the legal and ethical considerations surrounding lunar resource utilization, which is becoming increasingly relevant as more nations and private entities aim to exploit the moon's resources. The successful extraction and ownership of lunar materials could lead to a new era of space economics where lunar resources contribute to Earth-based industries and potentially support human life in space. 5. The importance of sustainable practices. The payload, including a water electrolyzer and a food production module, introduces elements of sustainability into the mission, as humanity looks to establish a presence on the moon. Understanding how to produce water and food in extraterrestrial environments is crucial. The successful demonstration of these technologies could pave the way for future missions where long-term human habitation is necessary. This focus on sustainability underscores a growing recognition within the space community that future exploration must prioritize not just scientific discovery but also the practicalities of living and thriving in space. 6. Future missions and technological advancements. The Resilience mission is merely a part of a space's broader strategy, which includes plans for additional lunar missions in 2026 and beyond. The company is already working on the next lunar lander, which will be developed by its U.S. subsidiary. This forward-looking perspective is vital as it showcases the potential for rapid advancements in technology and mission capabilities. The iterative nature of these missions allows for continuous improvement and innovation in lunar exploration technologies, which could have far-reaching implications for both commercial space endeavors and international space policy. Conclusion. While the successful entry of the Resilience lunar lander into lunar orbit is celebrated as a technical achievement, the significance of this mission extends far beyond that. The operational lessons learned, the blending of art and science, international collaboration, implications for lunar resource utilization, a focus on sustainability, and a commitment to future exploration all contribute to a more nuanced understanding of this event. Recognizing these aspects allows for a more comprehensive view of the potential future of lunar exploration and the role private companies like ispace play in shaping that future. As we move closer to the planned landing attempt on June 5, 2025, these details may influence how stakeholders, policymakers, and the public engage with and support future lunar missions. 1. Successful lunar orbit insertion and its significance. The achievement of the Resilience lunar lander entering lunar orbit on May 6, 2025 is a pivotal moment in the mission, marking a major milestone in the HAKUTO-R M2 mission. This successful orbital insertion, achieved through a meticulous 9-minute burn of the main thruster, showcases ispace engineering capabilities and sets the stage for the upcoming lunar landing attempt scheduled for June 5, 2025. The significance of this event extends beyond the technical success. It represents a critical step in the broader context of private sector involvement in lunar exploration, highlighting the increasing role of commercial companies in advancing space exploration initiatives. 2. Innovative payloads and scientific objectives. Resilience is carrying a diverse array of payloads, including the Tenacious micro rover, which is tasked with exploring the lunar surface and collecting regolith. Additionally, the lander hosts various scientific experiments such as a water electrolyzer and a food production module, which aim to demonstrate technologies essential for future lunar habitation and resource utilization. The inclusion of artistic elements like the Moonhouse installation by Mikael Genberg further emphasizes the mission's dual focus on scientific inquiry and cultural representation, making it a unique endeavor in lunar exploration. 3. Learning from previous missions. Following the failure of ispace's first lunar lander mission in April 2023, the operational experience gained has been pivotal to the success of Resilience's mission thus far. The company's CEO Takeshi Hakamata has underscored the importance of leveraging lessons learned from past endeavors to enhance current operations. This iterative approach to mission design and execution illustrates the critical importance of resilience and adaptability in the face of challenges, which are common in the field of space exploration. 4. Implications for future lunar exploration and commercialization. The successful entry of Resilience into lunar orbit and its impending landing attempt signify a step forward for ispace and the broader lunar exploration landscape. As the company prepares for subsequent missions, including those in collaboration with NASA's Commercial Lunar Payload Services (CLPS) program, this mission could pave the way for sustainable human presence on the Moon and establish frameworks for resource utilization. The focus on commercial partnerships and technology demonstrations positions ispace strategically within the emerging market for lunar exploration and resource development, indicating a shift towards a more sustainable and collaborative future in space exploration. 1. Apollo 11 Mission 1969. The Apollo 11 mission is one of the most iconic historical cases in space exploration, marking the first time humans landed on the Moon. On July 20, 1969, astronauts Neil Armstrong and Buzz Aldrin successfully landed the lunar module Eagle in the Sea of Tranquility while Michael Collins orbited above in the command module Columbia. Armstrong's famous words, "That's one small step for a man, one giant leap for mankind," signified not just a personal achievement but a monumental step for humanity. The mission demonstrated resilience in overcoming numerous technical challenges, securing U.S. leadership in space exploration during the Cold War and setting the groundwork for future lunar missions. 2. Mars rovers 2004, 2012, 2021. NASA's Mars rover missions have showcased resilience through their technological advancements and the ability to adapt to challenges on the Martian surface. The Spirit and Opportunity rovers, which landed on Mars in January 2004, were initially designed for a 90-day mission but exceeded expectations, operating for years. Opportunity lasted nearly 15 years before a massive dust storm ended its mission in 2018. The Curiosity rover, which landed in 2012, has provided significant insights into Mars geology and climate, further demonstrating resilience in its operations. Most recently, the Perseverance rover, which landed in February 2021, continues to explore the Jezero crater, searching for signs of ancient life and preparing for future human exploration. 3. Voyager probes 1977-present. Launched in 1977, NASA's Voyager probes Voyager 1 and Voyager 2 embarked on a mission to explore the outer planets of the solar system. Resilience is evident in their longevity and success, as both probes have transmitted valuable data back to Earth for over 4 decades, far exceeding their expected mission lifetimes. Voyager 1 became the first human-made object to enter interstellar space in 2012, and Voyager 2 followed suit in 2018. Their missions have not only expanded our understanding of the solar system but have also carried the golden records, which serve as a message to potential extraterrestrial life, symbolizing the human spirit in exploring and understanding our place in the universe. The successful entry of the Resilience lunar lander into lunar orbit on May 6, 2025 represents a significant milestone not only for space but also for the future of lunar exploration. This achievement is part of the HAKUTO-R M2 mission, which is set to attempt a lunar landing on June 5, 2025. Looking forward, we can anticipate several key developments and impacts stemming from this mission and the broader context of lunar exploration. 1. Enhanced lunar exploration capabilities. The successful operation of Resilience will likely pave the way for more sophisticated lunar exploration missions. With a space showcasing its ability to conduct long-duration missions and execute complex orbital maneuvers, we can expect further advancements in the technology used for lunar landers and rovers. Future missions may leverage the lessons learned from Resilience, particularly in areas such as propulsion, navigation, and autonomous systems. This could lead to more ambitious missions, including those aimed at human exploration and the establishment of lunar bases. 2. Increased private sector involvement. The achievement of a space signifies a growing trend of private companies entering the space exploration sector. As other firms observe the success of Resilience, we may see a surge in investment and innovation from private entities. Companies may collaborate on lunar missions, share technologies, and develop new business models centered around lunar resource utilization. This could result in a more competitive and active lunar economy with increased opportunities for commercial activities such as mining, tourism, and scientific research. 3. International collaboration. The partnership with various organizations, including NASA, and the involvement of international payloads underscores the potential for enhanced global collaboration in space exploration. As nations and private companies recognize the importance of lunar resources, we can expect cooperative efforts to address challenges such as resource sharing, environmental protection, and scientific research. This collaboration could extend beyond lunar missions to encompass broader space exploration initiatives, fostering a sense of shared responsibility and collective advancement. 4. Resource utilization and sustainability. The payloads aboard Resilience, including the water electrolyzer and food production module, highlight a growing focus on sustainability in space exploration. As missions progress, the ability to utilize lunar resources such as water ice for life support and fuel production will become increasingly critical. This could lead to the establishment of sustainable habitats on the Moon, serving as a proving ground for technologies that might one day be used on Mars and beyond. The emphasis on sustainability will likely inform future mission designs and operational strategies. 5. Cultural and educational dimensions. The inclusion of cultural artifacts such as the Moonhouse by artist Mikael Genberg reflects a broader recognition of the cultural significance of space exploration. As missions like Resilience unfold, they could inspire educational initiatives and public engagement in science and technology. The notion of carrying cultural messages into space may foster a greater appreciation for the human story in exploration, encouraging future generations to pursue careers in STEM fields. The integration of art and culture in space missions may become a hallmark of future endeavors. 6. Future mission planning and development. Following the HAKUTO-R M2 mission, ispace has already outlined plans for additional lunar missions, including the Apex 1.0 lander set to launch in 2026 and a Series 3 lander in 2027. These forthcoming missions will likely build on the operational and scientific knowledge gained from Resilience, as ispace continues to develop its capabilities. We can expect a steady cadence of lunar missions that will contribute to a more comprehensive understanding of the Moon and its resources. Conclusion: a new era of lunar exploration. The successful entry of Resilience into lunar orbit represents more than just a technical achievement. It symbolizes the dawn of a new era in lunar exploration and resource utilization. As we look ahead, the implications of this mission extend into realms of international collaboration, sustainable development, and cultural engagement, all of which will shape humanity's presence on the Moon and beyond. The coming years will likely see an acceleration of lunar exploration efforts driven by both public and private sectors as we strive to expand our capabilities and understanding of the cosmos.